Okay, my dear students, uh, I'm here with explaining some more problems related to the northwest corner rule as well as the penalty method and least cost method, all these things. Here you can see that example 1.2 consider the problem discussed in example 1.1 to illustrate the northwest corner method of determining the basic feasible solution. There are the factories, and from these factories, these are the retail agencies, and all these things are to be transported to various retail agencies located at point 1, 2, 3, 4, 5, and that the total capacity is nothing but it's mentioned here. So, like this, nothing but the demand requirement is nothing but the demand, and capacity is nothing but the supply. So 100, 60, 50, 50, 40, and amounting to totally 300, and it is also totally amounting to 300. Therefore, it is a balanced transportation problem because both the requirements and capacity are balancing. Now comes to this next one. If you go to the table and allocation of this particular thing, you see this allocation is shown in the following table. And here this is 124.14. So yes, this is the 124.14, 912, all these things are given. So first of all, if you go to the first corner, 11, x11, it is a demand is 50, whereas it is 100. So you see this 100 and this is 50. So you can allocate maximum 50 here. So he has allocated 50, and later it has come down and 50 to satisfy this vertical column. So horizontal column is satisfied, vertical column is satisfied, and he has striked out. So after the things are over, again in the staircase model, if you go horizontally, if you add 15 in this x22, x22, and horizontally it is balancing. So 100 units is balancing. Vertically it is balancing, horizontally it is balancing. So, but here again, if you come down extras, so you cannot allocate anything in these particular cells. So that is x23 or x24, x25, you cannot allocate anything. So second row, third column, like that. So again, if you come down like this, 50 plus 10, totally 60. 60, and initially first maximum, we can allocate maximum to this. And if you go horizontally, that is row, and vertically it is 100, you cannot allocate 100 here. You can allocate maximum 50 to satisfy this particular row. And if you allocate another 50 here by coming down, so you can satisfy the vertical column, first column. And again, after that, you come down yourself in a staircase manner. After that, this is 50, and horizontally it is satisfied. To satisfy the vertical column, you add 10, automatically it is 60. After that, so if you go to this particular thing, there is 150. Out of the 150, you have allocated 10 only. 50 allocate vertically satisfied. 50 you allocate vertically satisfied. Finally, 40 is left. If you allocate 40, automatically 40 is allocated. So like this, now he has given, to make you understand well, x11 is equal to 50, x21 is equal to the second row, first column, x21 is equal to 50, x22 is equal to 50. Next, x32, third row, second column. X32 means third row, second column is 10. 33, it is 50. And 34 is also 50. And third column, third row, fourth column, it is 50. And third row, fifth column, it is only 40. So therefore, he has calculated the total cost 15 to 1, 15 to 24. 15 to 1, 15 to 24, and 15 to 12, 10 into 33. 15 to 12, 10 into 33. Next, 15 to 1, he has mentioned here. 15 to 23, again he has mentioned here. 14 to 26, he has mentioned here. Total it is rupees 4420. So therefore, this is the total cost of transportation if you adopt the northwest corner method. So this is a particular problem. So like this, you can solve any problem if you are able to understand. Next, this is least cost method. This is also known as matrix minimum method. Matrix minimum method or least cost method, both are the same. Matrix minima, for the entire matrix, what is the least cost that you have to find out, and thereby you have to allocate. So similarly, column minima, row minima, they are different. So those are also the particular thing. So in this, if you go to this example, same thing, the least cost method of determining initial basic solution is illustrated with the help of the problem, the same problem. Now, if you check up 1, 24, 12, 14, 9, 12, 33, and 13, 16, 1, and all these things. Next is so among these, all these things, what is the least cost? There are three things. One is least cost here, second least cost here, third least cost is also here. Third least cost is also here. So there are three ones. How to select three ones? If you go horizontally, so this is 50 maximum, this is 100 maximum. And similarly, if you go this particular thing, 150 maximum, and here 50 maximum. 150 plus 50, it is 200, whereas it is 50 plus 100, again 150. And next comes to this. This is 40 plus 100, 140. So the least cost method is applying in the following manner. We observe that C11 is equal to 1 is the minimum unit cost in the table. Hence, X11 is equal to 50. Yes, consider this. And the first row is crossed out. First row is crossed out since the row has no more capacity. So 50-50 balance, hence it is crossed out. So then the minimum cost in the uncrossed out row section, C25. C25 means second row is nothing but that is 40. So this is the next least cost he has considered. Hence X25 is equal to 40 and the fifth column is crossed out. So if you allocate vertically 40 in this particular thing, so you can allocate 40, automatically this vertically it can be removed. So next comes to crossed out and X33. So that is column 33. This is nothing but column 33. So third row, third column is also 1 is there. You can allocate maximum 50 here. If you allocate 50, automatically vertically it can be crossed out. So because it is a simple problem, 1, 2, 3 are there, and initially we have to see which is the least cost, and after that we have to identify vertically and horizontally maximum allocations. So where minimum is there, that has to be identified. So that has to, so this is it is coming because it is 50, it is 50. Whereas in this it is 100, and whereas this is also nothing but 50. This is 50 and this is 150. All these things are maximum. Here it is 50 and horizontally it is 150 maximum. Whereas this is horizontal 50, vertical 100. It is somewhat less. And here it is horizontal 100, vertical 40, totally 140. So like that, he has taken this particular thing. Initially, he has to allocate this particular thing. Next, he has to go to this After that, he has to go to this particular 3 column. So this is a x25 is equal to 40. The fifth column is crossed out, and x33 third column is minimum cost. Hence, x33 is equal to 50. The third column is crossed out. Third column is completely crossed out. This third column is completely crossed out. And next x C22. So it is nothing but among all the things, if one is over and all the things are crossed out, you are left with this vertical column. You are left out with this particular vertical column. So 12 is the least among all the left out elements. So if this is the way you cannot understand, only thing is that you have to remove the columns. So therefore you have to go for the next iteration. So therefore 2 to 12 is the minimum unit cost among the uncrossed cells. 12 is the least cost among the uncrossed, hence x22. So how much you can allocate? Here 40 is over, 60 is left. You can allocate maximum 60 here. Vertically it is 60, balanced automatically, and the column is crossed out. Next thing is that next week look for the uncrossed out row and column. Now C31. So C31, this is 31. Third row, first column. 14 is the least cost. 14 is the least cost, and therefore you allocate 50. Automatically is the balance, and it is already allocated 50. And finally, if you allocate 50 here, it is also going to be balanced. So x31, 14, the minimum cost, hence x31 is equal to 50, and crossed out the first column since it was satisfied. Finally, 34 is equal to 23. 34 means this is 23, allocate 50, and the minimum cost, hence x34 is equal to 50. So like this, fourth column is crossed out. So if you crossed out all the columns and try to identify the uncrossed out columns or rows, and simply you can allocate, you will not have any much chance. 14 is the least, next to 23 is the least, and allocate this thing, finally allocate this 50 to this. So finally like that, everything is going to be balanced out. So it has to be done very carefully. And after that, 15 to 1, 15 to 14, 16 to 12, 15 to 1, and 15 to 23, 14 to 1 is the 14 to 1. So it is totally rupees 2740. So the minimum transportation cost obtained by least cost method is much lower than the corresponding cost of the solution in northwest corner. So if you calculate, this is 2710. 2710, it is 4420. In the northwest corner method, the cost of transportation is much higher, almost double. It is 2710. So this is the way you have to solve the particular problem. Next comes to Vogel's approximation method, that is penalty method. So VAM method is improved version of the least cost method that generally produce better solutions. The step involved in this are: step 1, for each row or column, strictly positive capacity requirement, determine the penalty by subtracting the small unit. So that is, I told you, minimum, first minimum, second minimum. First minimum, second minimum, this is the table, and he has repeated the entire table like this. So in this first column, 24 minus 28 is 4. Here it is 22 and 37. So 37 minus 22, it is 15 is the penalty. And it is 17 minus 9. So this is first minimum, second minimum. So like that it is 8. So next it is first minimum, second minimum. 7 minus 4, it is 3. And horizontally, if you check out, and this is 17 minus 4, it is 13. 9 minus 7, it is 2. First minimum. And here 20 and 15. First minimum is 15. Second minimum is 20 minus 15 is totally it is 5 differences. So like this, we have calculated the penalties. So among all the penalties, 13 to 5. 13 to 5 is there, and 4, 15, 8, and 3 are there. What is the highest penalty? 15 is the highest penalty. So therefore, look for the highest penalty in the row or column, the highest penalty. Second column, and the minimum cost is, among this minimum cost is 22. 22. Hence the assignment is nothing but 40 to this cell. 22 for this, if you allocate 40, and the vertical column can be removed automatically. So if you allocate 40, 120 minus 40 here in the next column. 120 minus 40. 120 minus 40, it is finally 80. Yes, crossed out vertical column by allocating maximum. Is 40 is the least cost is 22, 37, 37, 40. So this is the highest penalty. Against this highest penalty, and the least cost is nothing but 22. For this least cost cell, allocate maximum to the possible. Only you can allocate possible 40, and you can strike out the column, vertical column, whereas the horizontal it goes to 80. 120 minus 40, it 80. Now you try to identify the again penalties. Penalties means 17 minus 4, 13. 9 minus 7, 2. And again, this is 20 minus 15, 5. So first minimum, second minimum. First minimum, second minimum. First minimum, second minimum. Next comes to, this is like this, the penalties you found out. And whereas in this particular case, 20 minus 24, maamule, as usual. And you need not calculate. It is already crossed out. You need not calculate the difference here. A penalty, it does not exist. So here, 17 minus 9, 8, and 4 minus 3 is as usual. Among all the penalties, what is the highest penalty? 13 is the highest penalty. 13 is the highest penalty. And again, if you look in the particular row, what is the least cost here? It is nothing but 4. So how much you can allocate to this maximum? How much you can allocate? Only 80 you can allocate. So vertically, column wise it is 110, but horizontally you can allocate 80 here. And if you allocate 80 here, 80 plus 40 balanced automatically, the row will go out automatically. So this thing, so what he has already. So his 80 he has allocated, balance is 0, and it is crossed out completely. 80 plus 40, vertical column is also crossed out. Okay, next comes to the next table. Again, you have to identify the differences. You have to identify the differences. So among the left out elements, that is 32 and 24, what is the difference? 32 and 24, it is a much difference is there. He has still mentioned the old penalty. Old penalty, we are not supposed to. So because this is already crossed out, 20 does not exist. 32 minus 24 and 20 minus 9, he is mentioning the old ones only, not this thing. 20 minus 9 and 15 minus 7. Only thing is this, sorry, because they are not crossed. So 22 is going to eliminate, whereas 20 he has not eliminated, 18 and 17. Uncrossed out elements he has to take up only. So again, the confusing one, 20 minus 24, because it is crossed, it cannot come. So therefore, 4, 8, 3, 2, 5. Among the uncrossed, what is the highest? 8 is the highest. 8 is the highest means 8 is the highest penalty. So among 8 is the highest. What is the minimum cost? 7 is the minimum, 9 is the minimum cost. So he can allocate 9. How much he can allocate? 30 he can allocate only. He can allocate for 9. among this vertical column, 9 is the least cost. To this least cost, you can allocate a maximum of 30, and finally the balance is nothing but 40. So this vertical column can be crossed out. He has allocated 30 and crossed out this particular thing. He has maintained 40 balance here. So next comes to, again, you check out the differences. You check out the differences, and here he has mentioned horizontally, this does not exist because row is crossed out. And this is the difference is 24. This is penalty how 17 has come. 24 minus 7 is crossed out, crossed out, crossed out. All these things are. Only thing is uncrossed is 24, 32, so 17. And here the penalty is 8 again, 24 minus 32, 8. And this does not exist. And similarly, he is mentioning only it is also crossed out and is also crossed out. So here, the only thing is that the uncrossed is 24, 32. Remaining everything is crossed out. You need not go for any penalties and directly allocate the remaining things accordingly. For 24, so what is the balance here? So 10 is the balance. So 10 you can add like this because it is the least cost, and total it is going to be balanced automatically. 30, 30, 10 totally 70. So horizontally balanced, and the last one is nothing but the last one, there is nothing else. So here you can add 50. If you add 50, vertically it is going to be balanced. It is already balanced at 40. It is 30 balanced, and it is 80 plus 30, and 110 is already balanced. 110 is already balanced. So like this, after the allocations are over, so 10 is there here. Again for this, so 50 is there, hence 50 has marked it. Unless you remove the penalties, remove the strike out the columns, 50, 10 plus 50 here. So vertically 60 balanced, 40 balanced, 30 balanced, and 8 plus 3, 110 balanced, and horizontally 120 balanced, and this is also 50 balanced, and all these things are balanced, 50 balanced. So therefore finally this 10 into 24, 50 into 32. 10 into 24, 50 into 32. Next, this is 22 into 40. 22 into 40. What is this? 22 into 40. 22 into 40 is here. Next, 9 into 30. 9 into 30 is here. And 80 into 4. So 4 into 80. And 30 into 7. 30 into 7. Totally 3520. So 3520 is the cost of the transportation in this particular case. And whereas in this particular case, 2720, and least cost method, 2720 is the least cost method, is the transportation cost, which is minimum. Therefore, compared to northwest corner rule, Vogel's approximation method, least cost method is giving least cost of transportation, hence it can be preferred. So like that, so this is the way one has to solve the particular problem. So there are some other methods are there. So it is an unbalanced transportation problem. So here unbalanced transportation problem. What is unbalanced transportation problem? In the previous section, we discussed about balanced transportation problem. That is total supply, that is capacity at the origins is equal to the total demand at the destination. In this section, we are going to discuss about the unbalanced transportation problem. That is when the total supply is not equal to the total demand, which are called unbalanced transportation problem. If the supply and demand are not the same, then we are going to call it as an unbalanced transportation problem. So therefore, it is our duty to balance this particular transportation problem, convert the unbalanced into balanced one, and by creating dummy variables, and after that, only you can solve the particular problem. In the unbalanced transportation problem, if the total supply is more than the total demand, then we introduce additional column which will indicate the surplus supply with the transportation cost zero. Similarly, if the total demand is more than the total supply, an additional row is introduced and the transportation table which indicates unsatisfied demand with the zero transportation cost. So to convert the unbalanced into balanced one, you may have to create either vertical column or a horizontal row, and therefore you have to allocate, because it is our intention is to make it is balanced, and the cost of zeros are to be assigned. Zeros are to be assigned, and you have to make either supply or demand balance against the particular thing. Similarly, if it is a column wise, you have to create a vertical dummy column. In the dummy column, you have to create the particular zeros, costs, and thereby you have to follow the particular thing. So this is these are the warehouse 1, warehouse 2, warehouse 3, and this is a plant X and Y. There are two plants situated at different places, and 400 units, and totally 400 units, 500 units. So supply is 400 and 500. It is 900, whereas it is becoming 400 less. If you calculate 1300, it is becoming 1300, whereas it is 900. So you have to create one more row, and therefore this is 27, 25. Same row, 400, 10, 10, 20, and 500. And horizontally, one row has been created, 0, 0, 0, 400 he has marked. So therefore, 400, 400, 500 is amounting to 13. 400, 500, 400 is amounting to 1300. Now it is a balanced transportation problem. So this balanced transportation problem, we have converted this. Now with the northwest corner rule or least cost method, whatever it may be, we have to solve the particular problem, and thereby you have to analyze it. While multiplying with the zeros, automatically the costs are going to be zeros, and finally you will arrive at a particular solution. Next, a degenerate transportation problem. In a transportation problem, if a basic solution with m origins and n destinations has a less than m plus n minus 1 positive xij, that is occupied cells, then the problem is said to be degenerate transportation problem. The degeneracy problem does not cause any serious difficulty, but it can cause computational problem while determining the optimal minimum solution. So it is always to find out m plus n minus 1. So if it is a positive, number of rows plus number of columns minus 1 must be a positive 1, or else then the problem is said to be a degenerate solution. Therefore, it is important to identify the generate problem as early as beginning and take the necessary action to avoid any computational difficulty. The degeneracy can be identified through the following results. In a transportation problem, a degenerate basic feasible solution. In a transportation problem, a degenerate basic feasible solution exists if and only if some partial sum of supply is equal to the partial sum of demand. For example, the following transportation problem is degenerate because in this problem, A1 is equal to 400, B1 is equal B1, A2 plus A3 is 900 is equal to B2 plus B3. So this is Warehouse 1, warehouse 2, warehouse 3 supply. He has mentioned B2 plus B3, A2 plus A3 is equal to 900. A2 plus A3, B2 plus B3. So B2 plus, this is AI means A2 plus A3. It is 900 becoming B2 plus B3. B2 plus B3 means this is B2 plus B3. B2 plus B3 and A2 plus A3, they are becoming 900 equal to, and it is going to be degenerate basic function exists if and only if some partial sum of supply, either it is rho or rho, is equal to the same, then it's going to be called as a degenerate solution. Next comes to there is a technique called perturbation which helps to solve the degenerate problems. So perturbation technique. So the degeneracy of the transpiration problem can be avoided if we ensure that no partial sum of A and Bj is equal. We set up a new problem where A is equal to A plus D, Bj is equal to Bj, Bn is equal to Bn plus Md, where J is equal to 1 to M, J is equal to 1 to N minus 1, D greater than 0. This modified problem is constructed in such a way that no partial sum of the ASM is equal to the Bj. Once the problem is solved, we substitute D is equal to 0, leading to optimal solution of the original problem. So 2010, all these things, he is simply adding 400 plus D, 500 plus D, and 1300 plus D, totally 1300 plus 3D. So lastly, it is only adding 3D, depends on these conditions. Bn is equal to Bn plus Md, like that. And now this modified problem can be solved by using any of the three methods, northwest corner, least cost method, or VAM method. So this is a dummy variables, dummy cost. 400 is created, so 3Ds and 3D balancing. So totally, if you add 1300 plus 1300 plus D, these are not so important. You needn't bother. So transportation problem, there could be a situation where it might be more economical to transport consignment in several stages, that is initially within certain origins and destinations and finally to the ultimate receipt points, instead of transporting the consignments from an origin to a destination as in the transportation problem. So this is consider the following transportation problem where the origins are plants and destinations are depots, X, Y, Z, supply, all these things, and is 150, 450 balancing. 150 plus 300 and 150 plus 150, 450. All these things are balanced. This is cost of transportation. $1, $3, $15, $25, $5, all these things. And plant A, plant B, unit transportation cost from plant to plant A to B. This is another thing. Unit transportation from depot to depot X, Y, Z, depot X, Y, Z. X, Y, Z is 0, X, Y, Z is there. From depot to unit transportation got from depot to plant. So various combinations he has given. So depot X to plant A, depot X to plant B, depot Y to this thing. So various combinations. Like that, finally, we obtain the transportation formulation of the transportation problem, which is shown in the following table. So by combining the above three tables, table 1, table 2, table 3, and he is able to develop this particular thing. So AB, XYZ, AB, XYZ, supply, demand, all these things. And so X11 is equal to 150. The transportation problem explanation is as follows. So quantitative techniques for managers. So this is not required. Again, you have to solve it either this particular thing. You can solve this after the problem has arrived. You solve the problem either through northwest corner rule or least cost method or the Vogel's approximation method. So this is some other problem. A, B, C, D, X, Y, Z, capacity and demand. So it is 2600 and this is also 2600. Determine the suitable allocation to maximum the total return. So to maximize the profits, what is the best transportation? He is asking us. So he is solving in a different manner. This is not required. You solve this problem by usual method. Nothing but the northwest corner rule or least cost method or Vogel's approximation method or column minima or row minima method, whatever it may be, all these things. So this is not in syllabus, UV method, all these things. You need not bother. Only thing is that this northwest corner rule, which is nothing but the self-assessment questions. So as given is a particular problem 15, 20, 30, 35, 25, 26, 49. Totally it is amounting to 100. So this is also becoming 100, is also becoming, but transportation problem, balance of transportation, you can solve this automatically. So Modi method is not in your syllabus. Don't bother about this. Only 3 methods are in syllabus. So like this is also balanced. Solve this automatically. This is another example. He has mentioned a dollar, dollar, dollar like this, cost of transportation. So he has mentioned 800, 500, 900 and 400, 400, 500, all these things. You allocate against this particular thing, X, Y, Z. So these are the costs and A, B, C, D, E, respectively, the capacity of the plants is 800, 500, 900 per month. 800, 500, 900, you put it. And whereas the requirements of the warehouses, so nothing but 400 here, 400 here, 500 here, and 400 here, 800 here. Like that, you have to identify. After that, you have to solve them accordingly. So check out whether it is balanced or not. So therefore, see that it is balanced and then solve it. So sometimes the problem may be given like this, and you have to see that carefully. This is nothing but the capacity. Capacity means 800. So this is supply and this is demand. This is capacity and this is allocations. So like this, the next problem is again also 30, 30, 60 and is also 60s. Total is also a simple problem. You can solve this again in an ordinary manner. So he has given key solutions to these above problems. Further references, Taha is another book, Mustafi is another book, and you need not bother about all these things. So this is all about the transportation problems, where here you see this Saravana store, T Nagar, Chennai, interested to purchase the following type of quantities of dresses. Dress type quantities. Dress macro, dress quantity. So even you got demand and supply. Demand and supply. So this is the table cost of this particular thing from one to another, from A to allocation V. So this is 300, you put it here, 250, you put it here, 150, you put it here, 200, you put it here. And this is 150, you can put here, 100, you put here, 75, you drag here, 250, you drag here, and 200, you drag here. So like that, see that the sum of all these things, nothing but 150 plus 100 plus 75 plus 250 plus 200, calculate how much it is. Similarly, 300 plus 250, 150 and 200, calculate how much it is. Well, sir, both are satisfying, then you can treat it as balanced transportation problem. 300, 150, sorry, 250, 150, 200 here. And here it is 150, 100, and nothing but 75, nothing but 250, nothing but 200. So like this, all these things are to be carried out the particular thing. So you solve the once you are able to formulate the table, and you must be in a position to solve the particular problem either by northwest corner rule or by least cost method or Vogel's approximation method. In the examination, you will be always asked to find out either through northwest corner rule and least cost method. Identify which method is best, like that they are going to ask. Next, sometimes you may be asked, solve the problem by northwest corner rule and least cost, sorry, the Vogel's approximation method or penalty method. You have to solve by both the methods, identify the, you have to suggest which method is best depending on the cost of the particular transportation. So, and so with this, I'm winding up this particular transportation chapter, and we'll meet on Tuesday regarding the particular thing. Okay, I'm ending up this particular thing. I'm ending the particular total chapter. Okay, thank you.